welcome to our video on graphing tan of x graphs. In this video we're going to be covering how to graph these functions by hand, which is something you'll need to be able to do in both exams, but you'll need to be able to do it without a calculator. So before we get started, I've got the heading here, tangent graphs, and I want to make it really clear. Wow, that's a really thick pen. I want to make it really clear that we're talking about y equals tan of x, which is not the same as the function we looked at where you're drawing a tangent to any curve, and it's the line that just touches that curve. This is also called a tangent. But the one we're looking at today is a trigonometric value, which is this one here. Okay, I'd also like to remind you that tan of x is equal to sine of x over cos of x. And with that in mind, I've got a table here I've drawn up for various values of x in radians, you'll note, because there's a pi in these numbers. I've filled it in for y equals sine x, filled it in for y equals cos x, and I'd like you to fill in the final level for y equals tan x. Pause your video now to have a go at doing that. You should get something, well, you should get exactly these, not something like these values. Let's have a quick look at a couple of them. -1 divided by 0. We know in mathematics we can't divide by 0. It gives us either undefined, I would be happy if you wrote undefined here, or an infinite answer, infinity. Negative root 2 over 2 divided by root 2 over 2 is just -1. 0 divided by 1, we can divide by 1, so it's 0. And so on and so on. When we graph these values of y equals tan x, we end up with a graph that looks like this. First thing we need to put in are these infinite values. When we have an infinite value, it means that there's an asymptote at that value. So my asymptote is very faintly drawn here, so I'm just going to go over it. It's a good idea to put your asymptote in a dotted straight line so you can clearly see where it lies. So I've got one asymptote at negative pi over 2, which would be this one here. One at pi over 2, and one at 3 pi over 2. In between, my 0 values here and here are at x equals 0, x equals pi. And once we have the asymptotes and the 0 values, we can put the shape of the graph in. Now this is a periodic function, just like the sine and cos graphs, which means that it continues on. Function, make sure I spell that correctly, means it continues on forever. So usually you'll be told a restricted domain that you need to graph this function for, otherwise you just keep on drawing it forever. I want to highlight some of the main features here. First one is that amplitude is not relevant, because remember when we had our sine graph, and amplitude is this value here, how high the wave is. In our tan graph, it keeps going all the way up into infinity and all the way down into infinity, so we can't really find an amplitude. So we don't say that there is an amplitude for a tan function. The range is the y values. It goes all the way from negative infinity to positive infinity, which we can write as r. the period before it repeats itself. Some people like to think of it between here and here, which is one wave there. So between pi over 2 and 3 pi over 2, you should get pi. Some people like to think of it from here to here. You get this bit and then this bit here, and then it starts repeating itself again. Either way, you should get that pi is the period, which is different to sine and cos, which are 2 pi. Tan has a period of only pi. The vertical asymptotes we have here are negative pi over 2, pi over 2, and 3 pi over 2. Okay, let's look at a general function. For y equals a tan n of x, so generally the amplitude, we don't need to look at amplitude, but what we can look at is the number in front here, which is usually amplitude for sine and cos. What it is called is the dilation factor. And this is just the same as if you're drawing a parabola and you have your y equals x squared here, and you want to, I'll just label that y equals x squared, and you want to draw y equals 2x or y equals 10x squared, and it just makes it a thinner parabola. That's our dilation factor. If you have a fractional dilation factor for a parabola, it makes it a fatter parabola. So going back to our tangent graph, if we have a number for a between 0 and 1, then we have a fatter graph. And if we have a, so this is a fraction. Fraction means fatter. Fraction or a decimal. If we have a number, oh, not 0, a is greater than 1, then we end up with a thinner graph. I'm just going to have a quick sketch. An example of a thinner graph would look something like this, moving closer to the center, closer to a straight line up and down. And an example of a fatter graph would look something like this. They'll still have the same x-intercept here. The range for our y equals a tan n over x is just the real numbers. Now, next to vertical asymptotes, we need to write that they start at half a period. And I've forgotten to write the period in. The period has something to do with the n here. It's pi over n. The vertical asymptotes start at half a period, and then they are 1 period apart. Another way of looking at it is they are at pi over 2n and 3 pi over 2n. And you can keep going. 5 pi, this is 1 pi, 3 pi, 5 pi, 7 pi, 9 pi over 2n if you need to keep on going. If our period is pi for this one, our first vertical asymptote is at half a period, which is pi over 2. There we go. And then it will repeat again a whole period on from the first asymptote. You might like to pause the video now and have a go at drawing this graph yourself. Okay, looking at this equation, we've got a equals 1/2, which is a fraction. That's our dilation factor. So it's going to be fatter than the normal tan trig graph. Our period is pi over n, and n is 1/2. Pi over 1/2, which equals 2 pi. So our vertical asymptotes are going to start at half a period. So they'll start at half of 2 pi. So start at pi, and then they are 1 period apart. So the next one's going to be pi plus 2 pi, 3 pi. If we go backwards, there will be one at negative pi as well. So when you're drawing your graph, put your asymptotes in first. We've got a negative pi here, pi, and 3 pi, which is off the scale. Then we decided it was a slightly fatter graph than normal, so we can draw it. It's going to go through here, one cycle. And yours will hopefully look a bit more curved than that. Remember when you're drawing your graph that you make sure that it never touches your asymptote and that it doesn't flick back away from your asymptote. It needs to get closer and closer without ever reaching the asymptote. Once you've got the middle section in, you can get this next section sorted. And there we go. And there's your completed tan graph. Thanks for watching video today.